So, today I'm going to take you guys through the process I use for making shells in Blender, like the one I used for this hermit crab here. Alright, let's get started. So we're going to start by deleting the default cube and going into orthographic view, where we can then load in our reference image. Now, the image I used is a cross-section of a conch shell, and it helps if you can use a cross-section, but it's not necessary for this process. Now, if you set your image opacity, you'll be able to see the axis behind the image, which will help with the alignment. And we're going to try and align the image so that the z-axis goes all the way through the shell. It helps if you set rotation to be about the 3D cursor, as trying to align the image about its own origin can be tricky. In Blender, objects are added at the center of the 3D cursor, so we need to reset its position in the toolbar by setting the X, Y, and Z all to 0. And now we can add our empty, which is going to form the center of our modifier. Then by pressing G and Z, we can drag this down to the bottom of the shell. Next, we're going to add a plane, which is going to form the structure of the shell itself. Now, by pressing R and Y, we can rotate it about the Y-axis to be in the same orientation as our image. And then we can press Tab to go into edit mode and start dragging our vertices into position around the inside of the shell. By pressing E, we can extrude the vertices and roughly trace around the inside of the shell. Now, this doesn't have to be super accurate, and in fact, any detail we save here will be much appreciated. Because of the recursive nature of shells, it will be repeated many times, so even one less vertex is going to equal hundreds less in our final product. By pressing Shift-D, we can duplicate an unattached vertex and start on the outside of the shell. It's important to match the vertices on the outside to their counterpart on the inside, because we're going to attach them later. Bear in mind that the distance between the inside and the outside is going to be the thickness of our shell. Towards the bottom of the shell, it becomes a lot thinner, so we need to move our walls closer together to represent this. I mapped this bump using a trapezium shape, which will help our geometry flow better later. Here I have one more vertex on the outside than the inside, so we need to add another one on the inside with subdivide. Now our main shape is complete, and you can press Tab to exit edit mode. Next, we're going to add a modifier, and I'll show you why a screw modifier is not a good option. Currently, the modifier is set to duplicate around the x-axis, and we need to apply the rotation to prevent this. Now, like normal, it's around the z-axis, and we can set the center to the empty. Unfortunately, the screw modifier just doesn't have the customization we need to be able to replicate the shell structure. So instead, we're going to use an array modifier. Uncheck relative offset and set object offset, and choose the empty as our object. Be careful not to select the image empty, and select the axis empty instead. Since the offset is calculated as a difference between the origins, we need to set the origin of our object to be the same as our empty. From now on, any transformation we apply to the empty will be applied to the array instances, as you can see when we rotate it. A regular Blender cylinder has 32 vertices, so we'll set the count to 32, and then turn the empty until the array instances form a full turn. Now we can move and scale the empty to form the spiral of our shell. It helps to try and line up these with the cross section. Now we can increase the count to form the full spiral, and this will also help with alignment. Now this can take some time, so don't be too worried about not matching the shape completely, as this will still give us a really good shell to work with. Now we need to convert this wireframe geometry into actual geometry. So we'll start off by labeling it as shell, and then we'll duplicate the array. Currently, our actual geometry is only the things we added at the start, as you can see here. So when we apply the array, it will fill in the entire shell with actual geometry. As you can see, we can now select it, and we'll select the first two full loops, that includes inner and outer, and separate them. This will separate the loops into a separate object, and then we can just delete our original object with its applied modifier. When we toggle our array, we can see that the shell still appears. Basically what's happening is instead of duplicating a single loop, we're now duplicating two. Now between each loop we can fill in the faces, and it'll help if you select an edge and then hold F after creating your original face. And we need to do this for both the outer and inner loops. Now if we show the array again, you can see that our shell now has a surface. Unlike an actual shell, our walls aren't connected yet, so we need to find a way to do this and connect these vertices here. If you look at our image, you can see how it's connected all the way until here, where it eventually breaks apart again. To make our geometry flow nicely, this needs to be exact. We can't simply drag the vertices into position, as this wouldn't be accurate enough. So, we'll turn on snapping. The magnet icon controls snapping, and we can set it to vertex. But we still can't snap to these ones here. We can snap to our own. And why is this? Well, it's because we're using an array. This is the only actual geometry we have, and you can only snap to actual geometry. As you might realize, the solution is simply to duplicate our object, and then apply the array. So now we have actual geometry we can snap to. As you can see, we can now snap the vertices into position. I'll name this snap base, and to make it easier to see, we can delete this first loop. Now we just need to snap all of the vertices on this side to the wall. For now, this process doesn't have to be exact, but it will need to be eventually. So we'll just match the closest for now with the other wall. As you can see, we're missing a vertex here. And we're also missing them up here. It's easiest for this to use the loop cut tool, which will produce sets of vertices which we can then use to snap to the geometry of the wall, exactly replicating its shape. Let's hide the snap base and look at our shell object by turning on the array. As you can see, the wall is now continuous with the wall on the other side, like an actual shell. As I mentioned earlier, we need to match the number of vertices on the inner wall to the outer wall, so we can add more loop cuts here for that. To help with this, you might start filling in the faces to make sure that the vertices are matching. To make our walls actually have thickness, we need to fill in the bottom. This will make them replicated in the array with actual thickness, rather than just looking like thin planes. We need an object we can go back to with an unapplied modifier, so I'll rename this object to shell array UA, meaning unapplied. Then we'll duplicate it and make a new object where we'll apply the modifier. This is a good habit to get into, as once we apply the modifier, it's a lot harder to make any changes. To smooth out the shell surface, I'm going to add a subdivision surface modifier. Now this will drastically increase the number of polygons, but it's okay because it's non-destructive. As I start to fill in these rings, I notice a problem. Not only am I seeing some flickering, but also when I fill in a face and select an edge and hold F, it doesn't fill in. This is because Blender doesn't recognize this as a continuous surface, and this is because of our repeated geometry. The array technique produces overlapping vertices, which we need to merge with merge by distance. It's important to check the peak of the shell, because the geometry here is really close together, and having this number set too high will produce this ugly effect, which disrupts the flow of our geometry. When it comes to filling in this notch, you can't simply hold F, you need to fill it in by hand here. This is to produce a nice quad geometry all the way down. Now, where these three walls meet, you also can't just hold F, because Blender has a hard time realizing what's going on. But also, at this stage I realize I've made a mistake, and the geometry doesn't line up, so we need to start over. Luckily, we still have our unapplied modifier version. As you can see, I missed this little indent, and so I didn't do another loop cut. So, I'll rectify that mistake. Now, we just repeat all the steps up until then. When we add back our subdivision surface modifier again, you might see some creasing where we don't want it. And you can fix this by selecting all, going to Mesh, Normals, Recalculate Outside. As you can see, now the front is smoothed over again. To help Blender calculate normals, we need to delete interior faces, but as you can see we don't select any, even though they're there. This is because our shape isn't sealed yet, so Blender just thinks it's one big plane, with no inside or outside. When we seal these, by joining the faces like we did on the front, then we'll be able to select the internal faces. Now, by choosing Select, Select by Trait, and Interior Faces, we can see we are now selecting them. Now these faces actually sit between the outside and inside faces, as their name suggests, and they need to be deleted for Blender to calculate the outside and inside properly. Now, if we show our subdivision surface modifier again, you can see that our surface is nice and smooth. At this stage, it's a good idea to save the blend file, if you haven't already. To make our shell more interesting, let's add some surface features. To start with, I'm going to hide this face, and then the same face on the peak of the shell. This will allow us to only select the outside when we make our adjustments. By pressing Ctrl-Alt, we can select the edge rings. And as you can see, we're only selecting the outside ones. Now, if we choose Select, check a Deselect, we can select every other edge ring. Now, we just use Select Loops, Edge Loops. And now you can see we've selected every other edge loop, and we can now scale them to give our shell a nice, ridged pattern. Make sure to select the pivot point to be individual origins, instead of the 3D cursor like before. Now, By pressing S and Shift Z, we can scale them on every axis apart from the Z axis. Because of our close geometry at the top, any scale we make will be represented much highly up here. So we need to make sure that we're scaling the edges outwards in order to avoid overlapping geometry. Now our shape currently looks quite exaggerated, but this is just because our subdivision surface modifier will smooth it all out. Now you can see we have a nice ridge pattern on our shell, just like our reference. To make our ridges more defined, we can crease the edges with Shift E and 1. This will basically tell the subdivision surface modifier to ignore them and treat them like normal edges, while smoothing all the others. You might also want to crease the connecting edge, as I think this shows off the structure pretty well. By pressing Alt-H, we can show the face we hid before. Now, in a similar technique, let's hide the little trapezium we made before, on the front and the peak of the shell. Now make sure your selection is set to faces, and Alt left click. This will select all the outside faces along the little ridge. And now we can check a deselect again, to select every other one. Pressing Shift E and extrude faces along normals will allow us to extrude all the faces along their own axis, creating mini spikes. Now we can scale these faces as we wish to produce a spike profile that we like. Now you can stop there if you like, and I like the look of this shell. But I'm going to show you how to reduce the level of the spikes at the top, because I think they're slightly too long. So we'll duplicate our object and call it smooth. Then we can go into sculpt mode, select smooth, and just lower the strength, increase the radius, and smooth out some of the spikes on the top, decreasing their size. You just need to kind of play around with it a bit. And this kind of smoothing will mimic erosion, so the end result will look pretty accurate. Alright, now let's have a look at our finished creation in the render view. We'll select Cycles Render, and remember to select GPU Compute if you have a GPU. Select Denoise, and I like to choose a start sample of 10. Now we can see what it looks like with some lighting. This is kind of the orientation I would see a hermit crab using, so that's the one I'm using. In my next video, I'll show you guys how to produce a procedural texture using Blender's nodes. Thanks for watching, and I'll see you guys again next time.